Hi, boys and girls. Why do I always start videos like this? I have no idea. It could be the coffee. Someone said the other day I should probably stop drinking coffee. You can unsubscribe. Everybody else can subscribe. You unsubscribe. Don't tell me to stop drinking my coffee. I'll drink my coffee whenever I want to. This is like my 4th cup today. It's 5, almost 6 o'clock at night. Oh, yeah. So I must have been drinking a lot of coffee because I made it. A 7-page practice test. Oh my God, Mr. Krause. You are awesome. 7 pages of mathematics that I get to do in my free time. nkinfinity.com. That is the website where you can find all of these videos nice and neatly organized. And at some point in our life, you could probably get some of these items that we will eventually kick off to you. My name is Mr. Krause. You can call me Mr. Key for the next hour or so, however long this takes. Yes, I might have to stop in the middle and go get a cup of coffee, if you know what I mean. Hot. All right, here we go. By the way, I want to point something out. I'll highlight it for you. It says right here, make sure that you work through all of the problems on your own and then watch this video. If you're just here because I'm handsome, I know, the hair is looking pretty good today. That's why I wanted to make sure I cut this video today because my hair is looking pretty sharp. Yeah. You know it is. God, I love that stuff. Anyway, let's get going. So, Dr. Alibaba wants to test her new medicine. Now, I haven't proofread this, so there could be some really poor English in it. I hope there's not. Dr. Alibaba wants to test a new medicine that she and her firm have been developing. The first thing she decides to do is break her patients into 3 groups. In one group, she gives a dosage, that is, half sugar pill, half medicine. Weird. Second group, she gets the full dose of the drug. Okay. And the third group, they're the sugar pill people. Which type of study best describes this situation? Okay. So, it certainly isn't a census, because that would be just collecting data and asking everybody about something. She's not asking people things. And she certainly isn't observing what's going on. So this has to be a controlled experiment. Anytime you break groups up. Now, the only thing I didn't add in this controlled experiment, and that's really, really vital, and I probably should have added it in there, and I'll probably have to, maybe I'll go rewrite this. Maybe when you get this, it'll be in there. She should randomly, the word randomly needs to be in there. Randomly, oh, I know I didn't. Randomly, well, I should have put it in there anyway. Separate her patients into 3 groups, not just break them into 3 groups. Oh, there and there and there. There has to be some kind of randomness involved with it. That would be really important. Miss New was trying to determine the percentage of boys that actually wash their hands after using the bathroom. In order to do this, she used which kind of study? Let me make a little note there that we might want to fix that there thing. She used which kind of study? Okay, so designed experiment. I mean, I guess you could design an experiment, but, you know, what's the experiment? No. I don't think she'd ask them if they use I guess she could do a survey. Probably not the best, because, people lie. A random sample? Probably not the best. This would be the right answer. An observational study where she'd sit into the background. Now, you got to make sure you're not noticeable, because if somebody's watching you, then clearly you're going to wash your hands. But if she's just kind of figuring out, a way to be inconspicuous and still watch, then yeah, that would be an observational study. You can see what's going on. In order to determine the amount of time his students spend on their spiral, Mr. Krause specifically asked each student, I don't know why I need the word specifically. Why can we just go asked each student as they walked into class? Okay. How much time you spend in your spiral? How much time you spend in your spiral? How much time you spend in your spiral? Right? I wonder what that's going to give me. So let's go through these. We'll start from the end. Undercoverage bias means I missed a group. Well, if I'm asking everybody that comes in my class, I'm not really missing a group, and they're all about the same age. Not like I just asked the boys or just asked the girls. I asked everybody. Voluntary response bias. Now, it's voluntary if you respond because you want to, not because somebody asked you. So that's not voluntary response bias. Non-response bias means certain groups just didn't bother to respond to something. That's not what's going on. What's going on is what's called response bias. Your response to my question is going to be heavily biased by the fact that I'm pressuring you into answering the question. You're not going to say 5 minutes, loser. I hate your spirals, 5 minutes, right? Well, or Mr. Krause, I love you. I spent 4 hours and 23 minutes. That would be ridiculous. You know what I'm saying? That'd be crazy. But so there it is. That's what the response bias is. You're being biased by the person asking you. All right. The single best way to limit bias is to make sure that data is collected randomly. And I just put this on there because I want to make sure I drive home the point that anytime you're working with samples, surveys, questions, you want to make sure that you choose things randomly. Now, even if I chose my students randomly, like pulled out of a hat and decided which ones I was going to ask, and I asked them before they came in, then I would have response bias. Now, I would have a random sample, but I still have response bias. So even though you have created this amazing random number generator, perfectly picks randomness, if you sit there and ask the person a question, a question, you're going to get response bias, a lot of response bias. So that's just not going to work. Okay. The Hilton Central School District would like to know what the residents of Hilton think about having a 30,000 square foot sports complex built behind the high school, which was up for debate. Hopefully we'll get one someday. To do this, they decided to send out a survey to all of the residents of Hilton that are voting age. They received about 30% of the surveys back. Is this an effective way to determine the overall support or non-support for this complex? And we should explain. So, if you think about it, what happened was we sent out a survey and you got people's response, right? So what kind of bias do we have? We can go back up here, do we have a non-response bias? Heck yeah. There's a non-response bias going on here. It's not really voluntary response bias because voluntary response bias is, they just kind of leave cards on the table and you can respond if you want to. Or they don't even have to leave cards on the table. You just give your advice or your answer. Non-response bias means you're trying to get people to answer the question, but a lot of people aren't. So I would say the answer is not that. No, I'll try to be right neat. This is not an effective way to determine the overall support or non-support of the complex. Because only 30% responded, we have non-response bias in our data. Good enough. Something to that effect, so that I know that you know that getting 30% back, that ain't good enough. There's got to be some threshold by which you meet, and that's just not it. That's just why surveys just really aren't a great way to do it. Sending out surveys and then, only people that really feel strongly one way or another will respond. And does that really give you an overall feel? Probably not. All right, Mr. Garlock correctly surveyed. I thought I fixed this. Oh, no. Okay, yeah, I did. Mr. Garlock correctly surveyed the residents of Hilton. Correctly meaning he got a random sample. He got good data. He got, I did randomness. He got from all demographics. There was no response bias. There was no under coverage bias. There was no non-response bias. He just got a really good sample of what was going on in Hilton about whether or not they wanted to have the sports complex. However, he knows that almost 100% of the elder generation of residents vote when given the chance. He has heard that the elderly always vote down extra spending items. It comes a point in their lives, and I'm not saying this about everybody that's older, so don't call yelling at me going, I'm older and I'll support the kids. I know there's a lot of people, but a lot of people are on fixed incomes and they don't have an extra money to spend, and they don't want their taxes to go up, and you completely understand that. So what he wants to do, what should he do in order to either verify or debunk this idea? What can he do with the information? Well, the most clear thing that he can do is stratify the data. Mr. Garlock should stratify the data by creating groups, by creating or looking at different by creating or looking at different groups of data based on age. He can make comparisons between the age groups. Then what can he do with that information? Well, he can make comparisons between the age groups, but more importantly, at least if I'm in this guy, if I really want this thing to go through, then what I gotta do is say, if I see that, 90% of the elder generation is going to vote this down, and they've got the numbers to actually vote it down, because if 90% of the elder generation is going to vote it down, and there's a lot of people that are going to vote, that could really severely impact the vote. So I might get out to vote, or get the message out and try to get the message out to some of the younger people, some of the kids that have kids in the school district, to get them out to vote. So that's kind of what I'm looking for as far as that goes. All right, then this beast of a problem, and I apologize, this one's kind of a pain in the neck. So let me try to shrink this so we can see it. All right, so this represents our theater. Apparently we have 20 rows and 20 columns. So therefore there are 400 filled in seats. So what I'm trying to do is pretend like, now remember, these are 400 seats. Now, generally they wouldn't have all this information in there. And we have these clearly are the ages of people sitting in the seats. And I probably should have checked the fact that there were no zeros in there. I thought I got rid of those. Apparently there's a bunch of them. Wow, there's a bunch of zeros. Well, maybe nobody's sitting there. So I guess that's a seat where nobody's sitting. So we just will exclude those seats. How about that? I tried to get rid of them. I thought I got rid of them, but apparently the formula I used in Excel didn't work. So let's say a zero is somebody's not sitting there. So instead of going through and averaging all 400 numbers, what I'm going to do is take a random sample of 15 people and see if I can get an average age of the people that visited this play. So I'm going to take a simple random sample of just 15 numbers, and to do so, I'm going to use this random number table. So how does this work? So what I said in my directions is the first two numbers that I come to will represent the row, and the next two numbers will give me the column. And anything bigger than 20 I can't use, because I only have 20 rows by 20 columns. And so you have to make sure you leave no blanks, no spaces, don't jump over the spaces. The spaces are only there to help you read the data. So what are we going to do? I'm going to highlight. We got row 11 and row 16 and column 16. So row 11 and 16. This is going to be a pain. Row 11 and 16. So once you get the handle on what I'm doing, you're probably going to want to fast forward, because I'm going to go through these all. So if you don't understand it, kind of keep watching along. Now you're going to have to watch a little bit, because I'm going to try to do this with my pen. This next one will be 43. Can't use it. This next one will be 63. I can't use it, but I can use 18. Can't use 75. 18, 6. 18, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 18, 6 is 17. So there's the next one. And then, okay, I can use 13, but I can't use 76. I can't use 74. I can't use 26. I can't use 32. And then there's one, 7. So 13, 7. 1, 2, 3, 4, 5, 6, 7. 21. And I can't use 51. I can't use 0, 0. I can use 10. And I can use 12. So 10, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 74. So 12. And then I've got 4. 18. So row 4. Number 18. So that's 20, that's 19, that's 18. There's 4. Row 4, 18. And then row 19, can't use 22, can't use 89. 19, 17. 19, 20, 19, 18, 70. 17, 49. Okay. And then I can't use 92, I can't use 21, I can't use 21, I can't use 59. I can use 17. Can't use 91, can't use 76. So 17, 15. 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, fast forward once you get the idea of what I'm doing. All I'm going to do is get 15 numbers. What number was that? Okay. No 86, no 78, no 87, 5, no 43, 5, 16. So 5, 15, 14, 13, or 20, 19, 18, 17, 16, 72. So 72. Got a few left. Not 87, not 93. I got 20, and I can't use 53. Remember, you can't leave a number blank. So 53, can't use 36, can't use 85. 2019. So 2019, right here, 1. And then the next one, can't use 32. I can use 8. Can't use 46. Can't use 80. 8 and 4. 8. 1, 2, 3, 4. 68. And then can't use 84. Can't use 44. 82. 66. 55. 83. 76. 49. I can use 8, not 80. Can't use 29. I can use 8, 8. 8, 8. Remember, it's two different rows. One's row, one's column. 8, 1, 2, 3, 4, 5, 6, 7, 8. 83-year-old lady. And then can't use 70. I can use 12. Can't use 46, 24. 12, 18. 12 and 18. 72. And then I can't use, 12 and 18. I got 10 and 1. 10, 1, 66. And then I've got 80, can't use 60, can't use 29, 20, 77, 36, 79, 22, 62, 36, 33, 26, 66, 65, 83, 60, 88. There's go 19. Can't use 73, 19 and 20. 19, 20, 54, which is different than what I got before. So hopefully I got this right. 46, 13, and 2. 13, 1, 2, 47. All right, I don't know. I hope I got enough. I think I got enough. Let's see how many I got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like I got 15 numbers. So I need to add all those up. So I'm going to grab my calculator, which I forgot to turn on. So let me find out. So I should show my work, though, so let me highlight them all. can't really see them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 14, 15. Okay. So I should really write these down. So 14, I'll do it off to the side here so I can see. Oops, that's too big. 14 plus 72 plus 68 plus 83 plus 66 plus 74 plus 47 plus 21 plus, I missed something now, 74, 47, 21 plus 36 and 72 plus 36 plus 72 plus 17 plus 47 plus 49 plus 1 plus 54. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I add all those things up. All right, grab my calculator. I add all that stuff up. Go into calculator mode. All right, I think I forgot to put a 54 here. But when I added them all up, I got 721. I divided by 15, and I got 48.1. I think it said round to the nearest tenths place, 48.1. I will tell you when I did it the other way, on my own thing, I got 49.8. So either way, though, you'll notice, even though I got something different using my other way, I'm close. Now, I would have to do this more accurately. What's it going to say? Well, so look for the actual answer key. I think 48.1 is right. I think I did it pretty good, but who knows? I could be off slightly. Hopefully I didn't make a mistake. But you get the idea. The whole thing is I want you to get the idea. You would go through very, very slowly and do that. And maybe I'll give a little bit more space in between these numbers. It's kind of hard to knock off those numbers with this pen. That's my excuse. I'm sticking with it. All that to take an average. One page. Let's go back to bigger size. Oops. Why is that not doing that? Oh, whatever. All right. See what we got here. All right, I don't know why it's not doing that. Okay, so Mr. Luther would like to know what subject is favorited by the students at Hilton High School. He decided to survey 80 kids that entered the school. In order to ensure randomness, he decided to first ask the 23rd person. I don't know where he came up with that number. This is not good English. 23rd person 23rd person to come through the front door. That makes sense. And then ask every 7th person. This approach to collecting data is called hopefully you know this is called a systematic sampling. You've created a system, and that's what you're going to use to randomly select people. It's not convenience. That would just be asking somebody around. It's not observational, because that's just watching what people do. And it's not stratifying, because that's breaking up people into groups. Ms. Huff decided that Mr. Krause was crazy, and in order to collect her sample of students, she decided that she would ask the first 30 kids in the hallway. This approach is called CRAP, otherwise known as convenience sampling. Convenience sampling is just sampling what is easiest, and that's why you always got to be careful when you're talking about data. How did the person collect the data? Did they really, truly create a random sample so that you can really believe the data, or they just use what was convenient? Standard deviation can be best described as, well, the average of all data is a mean. The most frequent number is the mode. The difference between quartile 1 and quartile 3 is the interquartile range. This is the IQR, very important. And standard deviation is defined as the typical distance from the mean. In order to determine if a set of data had an outlier, which of the following procedures should you use? Determine what 20% above the maximum and below, so 20% above the maximum and 20% below the minimum and any number outside this range of numbers is an outlier. No, that's not what we do. Sounds good though. Find the average, the mean of the data, and create a range of that data that is 1.5 times the standard deviation from the mean. Any number, so basically you're saying take the mean and go 1.5 standard deviations away from that mean. No, that doesn't make any sense either. That's part of the normal distribution curve. Those aren't going to be outliers. Find the IQR, multiply it by 1.5, and subtract it. Man, I got to make some corrections. Subtract it from Q1 and add it to Q3. So you'll take your quartile range. You're going to go 1.5 IQRs this way, 1.5 IQRs that way, and anything out here would be considered an outlier. And yes, that is the way you determine whether or not something's an outlier. And then look on the data. Look at the data on the histogram. Any number far off to the right or left is an outlier. No, people want to say that, but that's not true. Label each of the following skewed left, skewed right, or symmetric. Then rank them 1 to 5, where 1 is the most variable and 5 is the least variable. All right, so let's go through and talk about shape first. This one, remember, skewness follows the tail. So this one is skewed left. This is highly symmetric. Symmetric just means the same on either side. This is I would say this is relatively symmetric. This is symmetric. And this is skewed to the right. So this would be skewed right. Hopefully you can see that. Skewed right. My big head's not in the way. I'll have to check that. Hopefully I check that. All right, now we're going to rank them. So I want to find the one that is the most variable. Now by most variable means we're going to take a net. And we're going to try a same size net every time. And we're going to try to collect as much data as possible. So if I created a net like that big, I can collect most of this data. If I swung that net through there, I'd collect almost all that. So I miss a little bit out here and I miss a little bit there. If I do this here, this would probably be the most, right? Same size net. Look at all this that I miss. I miss all this. You know, if my net was right here at a pole, I had my net, and I tried to collect all this data, this is all I would get. I would miss all of this. This, probably here, again, there's different size. So this one I would collect all of this. And I'd miss this, and I'd miss this. But, again, you know, this one is I collect here, I collect all of this. Wow, I almost leave nothing out. And again, this net here, I collect all of this. Leave this out. So the most variable one is this one. So this would be ranked 1. This is the most variable. This would be ranked 2. And then there's actually a tie for 3. That's why I say if you can't decide, give them the same number. There's a tie for 3. This would be third, and this one over here would be third. Because skewed right or skewed left, they really are both about the same variability. And finally, this one right here is the least variable one. Right here is the winner. That's the least variable, and that looks like a normal distribution curve. That's the one where you can use a smaller net and get lots of data. Okay? And so that's the idea of symmetry and how variable the data is. So make sure you understand those. All right, children, I'm back. So what I did was, while I had that video paused, I took this data and I went into my calculator. Of course, you got to go into your spreadsheet mode. And I typed in all those numbers into this spreadsheet. So what I want to do after I've typed this in is do some statistics, because in order to do a dot plot, I need, not dot plot, but in order to use a box plot, I'm going to need the 5-number summary. So I'm going to need to know a lot about this data. So I might as well do some work on it. So I'm going to go to Menu, Statistics, Stat Calculations, One Variable Statistics, and then click on OK, and we'll do it for test. I called them test. Could have called them test scores. Now, so let's get this information off to the side here. I got a X bar of 73.075. So I got an X bar of 73.075. Got a standard deviation. Now, this was everybody in this class, so I'm going to use the sigma 20.214. 20.214. So that's pretty high variability. That's a pretty high standard deviation. Means the scores are kind of all over the place. Min was 18. Now, in order not to go back and forth, I'm just going to write these down. Q1 was 60. Q2, or the median, was 78.5. Q3 was 89.5. And the max was equal to 100. All right, so a dot plot, and I wish this is going to be, yours must look better than this. A dot plot should have a scale along the bottom. All right, that's not actually too bad. And, this should be a 0. I guess out here will be 100. And then if I had a ruler, that would be 50. Let's go 10, 20, 30, 40. Maybe this is 50. Maybe this is 60. 70, 80, 90, 100, 110. So I guess I don't need this over here. But so let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. And put little tick marks at 5 so I know where 5 is. So you need to create a line here. Otherwise, it's not really a good dot plot. And if you want to scrub through, I think you understand how to do dot plots, but I'm just going to go through and put all these dots on. In a second, I'm just going to pause. So the first one is 18. Then the next one is 29. That will be right here. See, what the problem with it is they need to be at the same height as the previous one. That's why it's kind of hard to do it here. And then 35, 42. So 35, and then 42, and then 43, and then 52, and 54, and 55, and 57, 59, 61, 65, 66, and then there's another 66, so right above that should be another one, 68, 69, 72, 75, 77, 78, 279, so 79 and 79, 80, 81, 82, 83, 85, 86, 88, 86, 88, this pen's pretty good for this, 89, 90, sorry about that. Then I got 92, 92, 92. So there's our mode. 94, 96, 97, 98, 99, and we got 100. All right, so there's a dot plot. I should put a title on here. Mr. Krause's Unit 7 test scores. By the way, these are not accurate. Just made them up. Test scores. All right. So I'm making you think whether or not maybe we have some outliers or not. So making you think. All right. So that's a dot plot. Very simple. Box plot's just about as simple, except for you still need a number line. You still need a line down here. You still need a scale. Now our scale is going to run from 0 to 100. And then we're going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we're a little off with our 100. Sorry. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And I know that the low end was 18, so I'll put a dot right here down here for 18. And I know the high end was 100, so that's our min and max. I know that our quartile 1 was right here at 60, so that's going to be the left side of my box going this way. My quartile 2 or median was 78.5, so that'll be close to 80. So that's part of my box. Now we're going this way. And then my quartile 3 was 89.5, so that's right here, right close to 90. So there is my boxes and my whisker and my whisker. So, and again, you give it a title, Mr. Krause's Unit 7 test scores. But there it is. But if you don't have this scale down here at the bottom, the box plot, you know, and you should know that this is your 5-number summary. This is the min. This is the max. Quartile 1, quartile 3, and the median or quartile 2. And then comes the hard one. And I need to put this on here. I want to make sure that you have your bars are 10 width, just so they all kind of look the same. So what we're going to do is we're going to go by tens. So this is going to go I think I gave you 20 boxes. I hope I did. All right. So this is 1 to 10. 1 to 9. No, 1 to 10. 1 to 10. I don't know what happened there. 11 to 20. 21 to 30. 31 to 40. 41 to 50. 51 to 60. 61 to 70. 71 to 80, 81 to 90, and then 91 to 100. And we need to create a scale here. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And again, you need a title, Mr. Krause's Unit 7 score. So we're going to put our scale here. I know for certain that we only had one between here, and you should be kind of neat. Remember, your bars have to touch each other. And then between 20, I'm going to look at my chart here. Between 21 and 30, there was also only one. There was a 29. And between 30 and 40, or 31 and 40, there was also only one. Between 41 and 50, there were 2. Notice how your bars have to touch each other. And again, it's almost impossible for me to draw this neatly. You should be doing this on your own. And then I'm going to come back. I'm going to finish this in a second. All right. Then in between 51 and 60, let me just make sure. 1, 2, 3, 4, 5. 5. I'm going to come all the way up here to 5. And again, I apologize how sloppy I am. Normally, I'll be using a straight edge and make it look nice and neat. There it is, 5. And then it's between 60s, 1, 2, 3, 4, 5, 6. So I'm going to go up one more. Oh my God, I cannot tell you how hard that is. 70s, 1, 2, 3, 4, 5, 6. So 6 again. Oh, wait, we have an 80. There is an 80, so we're going to go up to 7. Remember, 80 is a part of this column, so I got to go up to 7, actually. This is kind of weird. Normally they don't go up like this. I don't know, maybe they'll come down. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, we just keep going up. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Jeez. Okay, that normally doesn't happen like this. Maybe I should maybe it wasn't the greatest data, but clearly this is skewed to the left, right? This is data that's skewed to the left. It actually almost looks like a cumulative frequency histogram rather than just a histogram, but it is in fact a histogram. So what I want to do is I want to describe this distribution. Now remember, you got to describe using shape, center, spread, and outliers. Now I can't talk about outliers until I do a little bit of work. So let me go back up to my math and let me go do a little bit of work. Remember, in order to do an outlier, the first thing you have to do is find IQR. So our IQR in this case is 89.5 minus 60, which is 29.5. And then we got to take that 29.5 and multiply it by 1.5. So we'll come over to our calculator. 29.5 times 1.5. 44.25. And then we got to take Q1 and we got to subtract off 44.25. So 60 minus 44.25 is 15.75. And Q3 plus 44.25. And you shouldn't be doing this where your dot plot is, by the way. 89.5 plus is 133.75. Now you'll notice this is our range for outliers. We don't have anything lower than 15.75. Our lowest number is 18. So although that's a really crazy low number, because this data had such a large standard deviation and it was quite spread out, which means my IQR was quite spread out, it also means that we're not going to have any outliers. So we'll use that information when we talk about this. So don't forget, you need to write something here. The shape of this distribution is skewed to the left. The center of this data as represented by the median is, was it 78.5? 78.5%. Spread. The spread, sorry if that's behind my head, so the spread of the data as represented by the IQR, interquartile range, is 44.25, which is really spread out. The range of outliers, Q1 plus, or excuse me, Q1 minus 1.5 IQR and Q3 plus 1.5 IQR would be 15.75 to 133 point, what was that number? 75. I think this was 25. Are they both 75? Maybe they're both 7.5. However, we have no scores outside of this range. Therefore, no outliers. There we go. All right, that's that problem. Woo, that was a lot of work. All right, kids, I decided to come back up here because I want to talk to you about one thing I forgot to put in this practice test, and I'll probably try to remember to talk about it in class, but if you're not one of my students, you're not going to get this from me. But what I want to do is talk about where the mean would be, and where the median would be. So what I'm going to do is I'm going to go through in green, and I'm going to put the median. Then I'm going to come back in a different color and put the mean. So if I was to do the mean of this data, or the median of this data, I would expect the median to be right about here. In this data, because it's a little bit heavier to the right, not much, I think what I would do is put the median right about here. This data, it's hard to tell which way we go, so the median, because it's symmetrical, would go right down the middle. And this one, the median would go right down the middle because it's symmetrical, and this median would be off to the left a little bit here. So that's where the medians would all go. Now, what you need to remember is the mean gets pulled towards the skewness. So if I'm over here on this first one and I'm skewed to the left, that means the mean's going to get, so we're going to do the mean in this big black letter. So that means the mean's going to get pulled off to the left. So that means because it's skewed left, my mean's going to get pulled over here off to the left. If it's symmetrical, the mean should be somewhere in the middle. The mean should be somewhere in the middle. In this one case, the mean will probably right down the middle. And because this one is skewed to the right, the mean is going to get pulled off to the right. Remember, these data points cause the mean to scoot off to the right or scoot off to the left because they follow the skewness. So don't forget that, okay? That's just something I forgot to put in the quiz or in the practice test. All right, so let's get going on some of these types of normal distribution curves questions. So the civil service exam given each year is not timed per se, but they do record the time a person takes to complete the exam and use it as part of the applicant's grade on the test. The latest Clerk 4 exam times for tests are normally distributed with a mean time of 190 minutes and a standard deviation of 22 minutes. So what percent of the applicants took between 168 and 202? So let's see. I think these first three are going to be relatively easy. So 190. If I just took this curve, if I just took this thing just the first time going through, and I said, all right, let's do this. You know, like you normally would do, and let's see what's going on here. So I got a mean of 190, and I got a standard deviation of 22. Well, if I go out 22, this is 168. And if I go up 22, that's what, 212? Oh, shoot. Yeah, that's my mistake. So this should be 212. I'm going to fix that. I got to fix that in the test. So this should be 212. So what percent is between 168 and 212? Well, one standard deviation, I remember, that's 68.2% as part of that empirical rule. 68.2%, one standard deviation. Now, if I go out one more standard deviation, this would be 146. And if I go up one more standard deviation, I'd get 234? Oh, that's what this one is, 146 to 234. If I remember plus or minus 2 standard deviations, that's 95.4%. And I have shown you how to use the calculator, how to do this, and I'll remind you later how to do this with using the calculator, because each one of these questions, I'm going to show you the pencil and paper method, and then I'm going to show you the using the formula, or using the table. And then if I go out one more standard deviation, I get 120, 4 and 256. And if I remember, that's plus or minus 3 standard deviations. That's 99.8% of the data. Okay? There you go. So what percent of applicants took over 200 minutes for the test? So what I will expect to see, and I'm not going to be very, very difficult. I'm very hard on you if you don't. I expect to see a drawing of a normal distribution curve because you were told it's normal. I expect to see the mean of 190, standard deviation of 22 in this case. And I want to see the conversion to a z-score. I expect to see that. I want to know what is our z-score for this one. 200 minus 190 over 22. Now if I do that in my calculator, (200 minus 190) enter, divided by 22, I get 0.45. So my z-score is 0.45. Okay, now I just want to go find my chart. Now I'm going to go to my chart, and I'm going to look up a z-score of 0.45. That's 0, 1, 2, 3, 4, 5. There it is right there. So 0.45. Remember, we don't care about the negative. So 0.45, it's 0.3264. Now, one thing I didn't do on my graph, which I'm very upset about, I should have done it, and I'm going to come back and do it right now, and that is I didn't talk about where 200 would be found. I should have said, oh, wait, hold on. I want 200. This is 200. And I want to the what? What percent of applicants took over 200 minutes? I want all of this. Well, remember, these give us the tail, and in this case, the tail is 0.3264. So this tail is 0.3264. So the probability that z is greater than or equal to 0.45 is 0.3264. Now, that's the probability. They asked for percent, or 32.65%. Now, again, I told you I was going to show you how to use the calculator. We're going to do it on every problem, just as a reminder. So we're going to go into menu. It's 5 for probability, 5 for distributions, and 2. So 552, normal CDF. My lower bound is 200. My upper bound is, if there's no upper bound, just put a whole bunch of 9s. Just keep putting 9. My mean is 190, and my standard deviation was, I believe, 22, correct? 22. And if I click OK, I get 0.3247. Now notice it's a little bit off, right? 3247, 32.65. So I'll know whether or not you used your chart or your calculator here, because this is a little bit more accurate of a z-score. Okay? The reason it's more accurate is because they use, in this table, they use 0.4545454545 rather than we just use 0.45. So that's why this is a little bit more accurate than what that table will give us. In the end, who cares? It's around 32%. I mean, do we need anything more accurate than that? Probably not. All right. Okay, in order to save a little bit of your time, I decided to I drew all the normal distribution curves in there for myself. Just help me out a little bit. So, what percent of applicants took less than 150 minutes? Well, 150 minutes would probably be somewhere down here. And I want less, so I'm going to shade to the left here. All right, so I want left. So I'm going to come up with my z-score. Z is equal to 150. Now, because it's to the left, my z-score should be negative. Minus 190 over 22. Grab my calculator. 150 minus 190, enter, divided by 22. And I get negative 1.82. So, and I knew it was going to be negative because my z-score my thing I'm testing is to the left. So my probability that z is less than or equal to negative 1.82. So now I got to go look at my table. 1.82, there it is, 0.0344. 0.0344. 0.0344, or because I want a percent, 3.44%. And again, let's grab the calculator and let's do it on the calculator. By the way, my calculator, when I go menu 552, already has a negative infinity in there. I mean, if yours probably doesn't, so put in negative, just put a whole bunch of, you're basically saying the biggest negative number that is so many standard deviations below, it doesn't matter. So you're just putting a huge number in there. In this case, my upper bound is going to be 150. My mean is 190, and my standard deviation is 22. I'm going to click on OK, and I get 0.0345, very, very close to what I got over here. Okay, good test. What percent of the applicants spent between 175 and 210? All right, where the heck is 175? So 175 is right here. 210 is somewhere over here. So I want in between. But remember, that's not what my tail test is going to give me. My tail test is going to give me this, and it's going to give me this. Even though I got to convert these to z-scores, I'm still going to have to figure out what those tails are and subtract. So my z is equal to 175. Now, since this is to the left, I should expect a negative. And then my other one is going to be 210. That's going to be to the right, so this should be a positive z-score. And I'm going to get both of these. 175 minus 190, enter, divided by. So negative 0.68 and 0.91. So what do I want to find? I want to find the probability that negative 0.68 is less than or equal to z is less than or equal to 0.91. And I'm going to figure out what that probability is and then write it as a percentage. Well, let's be careful here. Let's see what we're going to get. So we're going to go over to our table and we're going to look up negative 0.68. 0.68. Right there. 0.2483. I'm just checking my work over here. 2483. So 0.2483. And then let's go look up 0.91. 0.91 is right here, 1814. 0.1814. Now, what I got to do for this is because those are the tails. I got to get rid of them. I got to get rid of this, and I got to get rid of this, and that's math. Excuse me, that's subtraction. So we're going to do 1, which is the whole curve, minus the 0.2483, minus the 0.1814. So we'll do that in the calculator. 1 minus 0.2483 minus 0.1814. And we get 0.507. 0.5703, excuse me. So it's 57.03% are between those two values. Now, how can I use the calculator for that? Well, this is the beauty of this calculator. So we're going to go menu 552, menu 552. And then the lower bound in this case is 175. The upper bound is 210. And then the same thing, 190, 22. Click OK. There it is. 0.5706, right? So remember, it's a little bit more accurate than here, but we're good. We're good. All right. There's only 21 questions, but there's H parts on this one, so that makes it kind of tough. All right, here we go. In order to maximize the score, an applicant must finish faster than... Oh, okay, so this one's going to be a little tricky. Faster... Now, this one's really tricky, actually. Faster than 90% of the people taking it. What is the maximum amount of time? Okay, so if I want to be fast, that means I have to have a low time. So that means I want to be down in this tail, down here. I want to be in the low end. Don't think just because they say you want to be fast, which is big, normally fast is big, but remember with time, it's going to be the low end. And I want to beat 90%. So all in this area over here should be my 90%. Well, what does that leave me then for this little piece right here? Oh, that leaves me 10%. Now, remember, this stuff, the filled in stuff of the graph, is on the inside of the table. So I got to go look inside my table, and I'm looking for 0.10. So I'm going to find my highlighter because I want to freaking highlight this silly thing. 0.09. Nope. We got to keep going. Closer. Nope. Wrong way. 0.9. There it is right here. There it is. Look how close that is to 10%. That's 10.03%. That's as close as you're going to get. 10.3%. Well, that's a z-score of negative 1.2. Obviously, this is 8, right? Negative 1.28. So I need a z-score, of 1.28. And since it's off to the left, it is, in fact, negative 1.28. So I was able to find my z-score. So how am I going to figure out what score I need? Well, what I'm looking for in my formula of z equals x minus mu over sigma is I'm looking for x this time. So I've got my z-score, which I got from the table, negative 1.28. And then I'm just going to fill in all the other pieces. X, the thing I'm looking for, minus my average, 190, over sigma, which in this case was 22. We'll cross multiply. So remember, it's negative 1.28. So negative 1.28, and yes, it does matter, times 22, and I get negative 2816. So negative 28.16. Now, whatever number I come up with, it better be less than 190. Otherwise, I screwed something up, right? That's why you know, because when I'm going to add this 190 to both sides, if this wasn't negative over here, if this wasn't a negative, then it would be bigger than 190. That's why you got to make sure if you're on the left side, your z-scores have to be negative. And then I'm just going to add 190. And I get 161.84. So 161.84 minutes. So that will be how fast you have to be. And that's not what I got here. I got 168.84. How did I do that? I got all the same numbers. 28.16 plus, I must have just, yeah, I just wrote it down wrong. Anyway, there it is, 161.84. All right, next problem. A person with a score that lands them in the slowest 20%. Now, the slowest 20%, because this is timed, would be over here. This would be the slowest 20%. That means there's 80% over here. But again, we only want to look up 20%. So we're going to go back to our table, and we're going to look up 20.20. Well, that's going to be further down here. Let's see. 0.2 looks like this is it right here. That's going to be the closest. So that's negative 0.801234. Negative, oh wait, we're to the right though, so it's going to be positive 0.84. So 0.84. Remember, we're ignoring the fact that it's negative or positive, but we have to remember what's going on here. Now I'm going to go back and show you how to use the calculator on these just to make sure we got them right. So z is equal to, we don't know, minus the mu, which is 190, all over our standard deviation. Oh yeah, we know what z is. We just looked that up. It's 0.84. So 0.84 times 22, 1848, equals x minus 190. Add 190. And I get x equals 208.48. Didn't say it around. There it is. Oh, it said not rounded there, 1/10 of an hour. So x equals 208. Oh, I should say minute. 208.45 minutes. Let me correct that. 200. Huh. What number are we on? H. Oh, I didn't even have it on here. I'll have to fix it in a minute. All right, there we go. All right, now how can I use my calculator to check that? Very simply. So let's go back to our calculator. And we're going to say, okay, menu 552. On the first one, We want it to be negative infinity up to, we said 161.84, 160, oops. So this is our negative 99999999999 all the way up to 161.84. Our mean was 190. Standard deviation is 22, and we're hoping this comes out to be 10%. There it is, 10%. That's what we're looking for. And then the other one, menu 552, we wanted our low end to be 208. Let's use the 0.48 because we're still looking for that 20%. Upper bound is 99999 and forever and ever and ever and ever and ever and ever. 190, 22. Okay, and there's our 20%. So there's a quick way to check to see if you got the answers right on the more difficult questions. Okay, kids. Oh, my goodness. We got 15, 16, and then some singleton questions. So the salaries, I should have graphed these already. So while I'm talking, let me just do these. So the salaries, we're talking about the salaries at the Juergens and Schmidt baseball firm. They're normally distributed. They got 300 employees. I'm not sure if that's going to come into play or not. Might. They're normally distributed with a mean of 14.5. Since I'm running out of space here, I'm just going to do this 14.5. And a standard deviation of $1.22. Mean of 14.5. I should have given you more room here. And a standard deviation of 1.22, $1.22. And again, in all of these, we got a mean of 14.5 and a standard deviation of $1.22. Okay. So that's what we got in all of them. What percent of the employees are greater than 1520? All right, so let me put in 1520. That should be off to the right here. 1520. And I want greater than 1520. That would be all these. So we'll do a z-score. 1520 minus 1450 all over 1.22. This gives me a z-score of, I'm going to check my work, 15.2 minus 14.5, enter, divided by 1.22 of 0.57. So the z-score of 0.57, I'll go over to my table. I'm going to look up 0.57. 987, 2843. So I come back to my table. Gosh, that's annoying. Forgot what I said. 2843. 0.2843. So the probability that z is greater than 0.57 is 0.2843. It asked for what percent in this case, so we're going to use 28.43%. But remember, if I ask for probability, that's what I want. If I ask for percent, that's what I want. And I think I was very boring on this test. I just kept saying percent. Less than 13.25. So there's 13.25. We want less than. So now, because we're to the left of the mean, we should have a negative z-score. So z is 13.25 minus 14.50 divided by $1.22. And we get a z-score of 13.25 minus 14.50, enter, divided by 1.22. 1.02, negative 1.02. So probability that z is less than or equal to 1.02. Probability would be, let's see, 1.02, 1.00, 1.01, 0.1539. Remember, this is 0, this is 1, this is 2 over here. So 0.1539. So the answer is 0.1539 or 15.39%. Didn't say the word around, I don't think, so we'll just leave it like that. And finally, what percent is between 14, which is really close here, and 16, which would be over here? So what percent is in this range right here? Well, of course, we got two z-scores to do. So we got z equals 14 minus 14.50 over $1.22. And we got z equals 16 minus 14.50 over $1.22. So we got to come up with those two z-scores. So 14 minus 14.5, enter, divided by $1.22. So it's negative 0.41. Negative 0.41. And the other one is 16 minus 14.50, enter, divided by 1.22, 1.23. All right, so we got some z's, we got those to look up. 0.41. 0.41 is 34.09. So remember what that gives us, though. Remember, that's going to give us all of this, right? That's going to give us all this, and the other one's going to give us this. So we're going to end up subtracting on this one. So this one is what was that, 3409? 3409. Let's look up 1.23. Oops. 1.23. 0, 1, 2, 3. That's 1093. So 0.1093. So let me do it off here. The probability that z is negative 0.41 less than or equal to z less than or equal to 1.23 is 1 minus 0.3409 minus 0.1093. So I got to grab my calculator. 1 minus 0.3409 minus 0.1093. 5498. 0.5498. So the answer to this one is 54.98%. Approximately 55% are between those two scores. And that kind of makes sense, right? You're, right there in the middle, you're going to have a big bulk of the numbers in there. Oh, got one left more. Nick Roloff says that his salary puts him in the top 5.1%. Let's see if that's true. Sigma equals $1.22. So he thinks he's in the top 0.0510%. So we got to kind of look up that and try to remember, since I'm looking up inside the standard deviation curve, I'm actually looking up a probability. I got to look on the inside of the chart. Now, if in fact it's 5%, that should be close to the tails, right? That's going to be a big number. So we got to look up 0.051. This looks like probably the closest I'm going to get, because that'd be 0.051. That would be that'd be basically 0.05. So this is the closest one. So negative 1.64. So the z-score of negative, or not in this case, it's going to be positive 1.64. So we want to find out what his minimum salary is if he is in fact in the top 5% of this company. So we know that we have a z-score of 1.64. We don't know what his salary is, but we do know that the mean is 1450 and the standard deviation is $1.22. So we just, in this case, again, we're looking for the x value. So we'll cross multiply. 1.22 times 1.64, enter 2008. So 20008 equals x minus 1450. I'll add 14.50 and I get 1650. So x equals 1650. So the least amount of money that Nick can make is $16.50. All right, we'll be back. Oh, these are cool questions. They're all cool. All right, the Matthews Nellis Butcher Shop purchases 1,000 steaks a month from the Sherwood Farm. The weight of the steaks are normally distributed, so there's the important words. Boom, allows me to draw my normal distribution curve. with a mean of 12-ounce steaks, 12-ounce steak, and a standard deviation of 0.9 ounces. All right, the Matthews, Nellis and Matthews will not accept any steak less than 10 ounces. How many steaks, S-T-E-A-K-S, how many steaks will they on average refuse to accept? Well, the first thing I do is figure out what's going on here. So let's see. 10 ounces is going to be to the left here. So anything less would be over here. So that's what we're going to refuse. So I got to figure out what that is as a z-score. So I'll go z equals 10 minus 12 over 0.9. 10 minus 12 entered divided by 0.9 equals negative 2.22. So equals negative 2.22. That's my z-score. So I want the probability that z is less than or equal to negative 2.22. So I go look at my table. Negative 2.2012. 0.0132. 0.0132. All right, but that's a probability. Don't forget, this case I'm asking how many. So what I got to do is I got to take my 1,000 and I got to multiply by 0.0132. Now we don't need a calculator for that. It just moves the decimal place over 3. So on average, 13.2 steaks will not be accepted. I think what I would be looking for there is approximately 13 steaks would not be accepted. So they would reject 13 of the steaks. Okay? So let's go to the next problem. Arbori and Andrews just got done working on a dude ranch. The cattle they raised this past year have an average weight of 2,450 pounds with a standard deviation of 40 pounds and are normally distributed. They have 700 head of cattle and know that the buyers will only take cattle that weigh over 2,400 pounds. How many steer will they sell? All right. Did I say it's normally distributed? Yes, I did. There it is. So, got our normal distribution curve. Average of 2,450 and a standard deviation of 40 pounds. They will only take cattle that are over 2,400 pounds. So there's 2,400. They're only going to take these. But I can't look that up. The only thing I can look up, remember, is I'm going to look up this tail here. But I still got to turn that into a z-score. So z equals 2,400 minus 2,450 all over 40. Now that z-score is, what's that, 1.25? Negative 1.25. If you did that, I'd calculate it negative 1.25. Now remember, that's going to give us just this part here, which is not really what we want. That's the less than part because the chart only gives us the tail, but that'll be okay. So 1.25, 1.20, 1, 2, 3, 4, 5. There it is, 1056. 0.1056. So 0.1056. So how much will they accept? So, okay, so the probability that z is greater than or equal to negative 1.25 is equal to 1 minus 0.1056. And so I'll go over to calculator, 1 minus 0.1056. And I get 0.8944, 0.8944. So they will accept 89.44% of my cattle. I have 700 cattle. So I'm going to take 700 multiplied by 0.8944. And I get 626.08. 626.08. So they will accept 626 of my cattle. None less. The 0.08 doesn't count. 626. All right, we on the last page? Yes, last page. All righty, kids, we got 4 left. All right, once again, we have a fight of the century on our hands. Marta and Nace both got a 92%. Both got a 92% on the Unit 8 assessment. They want bragging rights as to who did better on the test. Marta's crazy teacher, crazy. So let's talk about Marty. She got a 92, Marta, not Marty. Marta got a 92% on the test in Crazy Lady's class. The average on the test was an 80%, and the standard deviation was 7.8. In Anais's class, she got a 92%. We got an average of 88% and a standard deviation of 2.3%. So if I just look at this, you could say, oh, Marta beat the average by 12 percentage points, whereas Inés only beat the average by 4 percentage points. So clearly Marta did better. But that is not how this is done, and you better not make that basic statement. That's not how it's done. We have to convert these to z-scores. Really, all we do is need to convert them to z-scores. So we're going to take Marta's 92, we're going to subtract off the 80, and we're going to divide by 7.8, and we're going to get a z-score. So 92 minus 80, enter, divided by 7.8, and you get 1.54. 1.54 is her z-score. Whereas Anais, let's see, her z-score will be equal to 92 minus 88 over 2.3, which is really just 4 over 2.3. And her z-score is 1.74. Now remember what that means, kids. A z-score of 1.54, or Marta, would be here, and she beat all of these people. Whereas Inés got a z-score of 1.74. Marta beat all of these people. Inés beat all of these people. So Inés did better. And if I look up their z-scores, so if I actually look up the probability, which I don't have to do, Inés won. Inés did better. But if I look up their z-scores, the z is, remember what it's going to do is it's going to give us the tail. So the probability that z is less than or equal to 1.54 is equal to 1 minus whatever I look up. So I'm going to look this up. What is it? 1.54. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0.0618. So it's going to be 1 minus 0.0618. 0.0618, which is equal to 1 minus 0.0618. I get 90. She beat 93.82. 93.82. So she beat 93.82. Now let's look up Inés at 1.74. 1.74, 0, 1, 2 is up here, 0.049. So the probability that z is less than or equal to 1.74 is equal to 1 minus I forgot what that number was, 0.409. 0.409, 1 minus 0.0409. She beat 95.9%. So they both did really, really well, and Ace did slightly better just based on her population. All right. Fisherman Fair just discovered the largest blue whale ever. The estimated weight of the blue whale she discovered was 204,000 pounds. The average weight of blue whales is known to be 170,000 pounds with a standard deviation of 13,000 pounds. So, okay, let's talk about the blue whale. We got X bar of 204,000 pounds. We've got a mu of 170,000 pounds. And we've got a standard deviation of 13,000 pounds. The average grizzly bear is 600 pounds, so let's talk about the grizzly bear. The mu is 600 pounds with a standard deviation of 22 pounds. If Brendan, the bear hunter, were to find a comparably sized black bear or grizzly bear, how much would it weigh? So we don't know what it is. We want to know what a comparatively sized. Now, so what I mean was, you know, this whale that she caught was so drastically ginormous. What size grizzly bear would equal that same drastic size difference of the new one? So we got to do a little work. So we want, basically what we want is their z-scores to be equal each other. So we're just going to figure out what the z-score is over here. 204,000 minus 170,000 over 13,000. So 204, 123, minus 170, 123, enter, divided by 13,000. And I get a z-score of 2.615 or 2.62. So this is 2.62 standard deviations above the mean. Maybe it's not the biggest whale ever. Maybe there is a bigger whale. So let's see how big this grizzly bear would have to be. Well, it has to equal the same z-score. So 2.62 has to equal that same z-score. So minus 600 divided by 22 again. So we're going to take that z-score we just came up with, multiply it by 22, and we're going to add 600 to it. And I'll show you that math in a minute. 57.54. So 57.54 equals x minus 600. Add 600, and I get 657.54 is that. So a bear that weighs 657 pounds, 0.54 pounds would be just about the same relative size as that big blue whale that Miss Fair caught. All right, 2 more questions. All right, kiddies, we got a little bit left. 2 left. The mean weight of 18-year-old boys is normally distributed. 18-year-old boys is normally distributed. There it is. With a standard deviation of 7.5 pounds. What is their mean weight? So we don't know mu. Rounded to the nearest tenth of a pound if 21% of them weigh more than 170 pounds. So here's 170 pounds. Now the reason I'm able to put 170 pounds over here is because I said 21% weigh more than that. Well, okay, so I know it's got to be up here somewhere because, you know, if I picked here, if I picked this and went over, that would be 50%, you know. So this has to be about 0.2100%. So since we're looking inside of this, I got to go over to my table and look on the inside. Now this is going to be a little tricky. I got to find 0.21%. Sometimes it's not that easy. 0.21. Let's see, 0.21. I would say this one probably rounds to 0.21 the closest. Right? What is that? Negative. Well, in this case, it's going to be positive 0.81. So 0.81 standard deviations. Why did I pick 0.84? Oh, wait a second. Yeah, I picked the wrong one. Oh, that one says 21.1%. Did I change the problem? Shoot, where am I at? Oh, yeah, it's just 21%. Okay, so I changed the problem slightly. So we will use 0.81. So our standard deviation is 0.8, or our z-score is 0.81. So 0.81 equals, we do know the observed value, what we're looking for. What we're looking for is what is the mean. Remember, this is where the mean goes. So put that mu there, all over our standard deviation of 7.5 pounds. So we'll come over to our calculator, we'll take 0.81, we'll multiply it by 7.5, and we get 6.075. So 6.075 equals 170 minus mu. We're going to subtract 170. So minus 170. Negative 63. Oops. minus 170, negative 163.925. So negative 163.925 is equal to negative mu. In other words, mu then is equal to 163.925. 163.925. All right. And it's rounded to the nearest tenth of a pound, so the mean weight would be 163.9. All right, last problem. The effective radius of the new buckered bombs is normally distributed, boom, with a mean of 1,400 meters. If 18.1% of the bomb's effective radius is over 1750, so there's 1750, and 18.1%. So again, we're looking on the inside, 0.1810, as my probability is on the inside. What is my standard deviation? So first things first, we got to go look up a z-score. So we're going to look up 0.8181. 0.181. 0.1814. 0.181. Oops, we're going the wrong way. 0.1814. Is that it right there? Negative 0.91 or 9.91. That's the closest I'm going to get to 0.181. Right? I'm really close. 0.181. There it is. So that's point. Remember, I don't need the negative because I'm to the right. Or remember, my number is bigger. So 0.91. 0.91. Remember, I'm to the right, so it's got to be positive. So 0.91 equals my 1750, my observed value, minus my mean, 1,400, over my standard deviation, which I don't know what it is. So, this should be 1750. So we're going to cross multiply. 0.91 times the standard deviation is equal to, what is that, 350? And then we'll divide by 0.91. This is a ridiculously bad answer. So 350 divided by 0.91. Enter. 385. So my standard deviation is 385.615. So 300, yeah, there it is. That's kind of a dumb answer. So anyway, there it is. That's the mean. There it is. That is your practice test. Good luck. I know that took forever. Please hit the subscribe button, hit the like button. Hopefully you learned something from what we did in the last 4 hours and 33 minutes and 22 seconds. I'm ready for bed. It's only 7:30. All right, kids, have a good night. Catch you on the flip side. Hit the subscribe button, please. Thank you. Goodbye. No, really, goodbye. No, really, you got to go. If you're still watching, you're crazy. Okay. We're going to have a staring contest. I bet I win. Made you laugh. Bye.